Alrighty guys, so you made it to question 20, which is going to be a question that's asking us to complete the following mechanism. And so for this mechanism, we're going to be using a lot of arrows to demonstrate where electrons are going, bonds are being formed, bonds are being lost. And so just starting right off the bat, we're given the arrows that show what our compound A is going to be. And so by looking at these arrows, we can see that we have a T-butoxide here, oxide being the negatively charged oxygen there, is going to be taking a hydrogen, and in taking that hydrogen is going to be leaving its electron behind. And so when hydrogen leaves its electrons behind, we're either going to have a lone pair of electrons floating around, or we're going to form a double bond. In this case, we're forming a double bond here, but in doing so, we create too many bonds on sulfur. We get 7 bonds on sulfur, and so that's why one of these bonds has to come up here onto the oxygen, and it makes ultimately a lone pair hanging around that oxygen, making it negatively charged. So I've drawn out what that would look like when we do that. We've got that double bond, and then we got that double bond that was on the oxygen came up to become a lone pair. We still have one hydrogen here, but keep in mind we lost the other one. Alright, so we've got our A compound, and so what's going to happen next looks like we're going to have step 2 is the loss of the bromine, forming a carbocation. So we're thinking this is going to be an SN1 reaction. Not necessarily sure if that's even required, but just the formation of a carbocation, you're thinking SN1 or E1. So let me go ahead and put A over here. And now what's going to happen is we're going to lose that bromine. And so in losing that bromine is going to take its electrons with it, and that's going to make the bromine negative. And then if that bromine is taking its electron, that's going to leave this as positive. It's going to leave that CH2 there as positive because it took its electrons with it. And so here is that bromine on its own, so we're going to go ahead and erase this bromine and make this our carbocation. So that's what our B compound looks like. That's the carbocation formation. All right. And so now our step 3, 3-member ring formation. Now, this is where it gets a little tricky. I should say very tricky. And the reason is you need to form a 3-membered ring out of this structure without adding or taking away anything. And one of the things that hint towards that is the fact that you have a negative and a positive charge in the same compound. That's generally not something we want, and usually we find a way to stabilize it to where we don't have any charges, and so that's exactly what we're going to do in this case. So what we can do is start looking at resonance. We've got this extra pair of electrons that we can actually bring down to form a double bond here. Now we can take 2 options here. The first being that we just move a double bond back onto this oxygen over here. That would be a resonance structure. But our other option is that we can do something with this double bond here. Because when we brought down this bond, we created 7 bonds on that sulfur, meaning we're going to have to get rid of another bond. And so that three-member ring formation is actually going to occur with that bond, and that bond is going to reach over to that positive charge. So again, just real quickly, we're going to bring down these electrons, forming a double bond there, giving sulfur too many bonds, meaning we're either going to have to get rid of a double bond here or here. And then in order to form that 3-member ring, we're actually going to get rid of this double bond and connect it to that positive charge over here. And so when we do that, so let me go ahead and draw that arrow real quick. when we do that, that stabilizes that positive charge because we're giving it electrons. And so what our C would look like I'm going to go ahead and erase this since we're done with it. What our C would look like is it's going to have a 3-member ring within it. Because remember, we just got rid of this over here in the last reaction because we brought the double bond down and then we turned that double bond into a 3-member ring here with a carbon, carbon, sulfur being the 3 members of that ring. So now we've got our 3-member ring. Let's see what our next step is going to be. And notice here that this is the step that does not have an additional compound, and that's because we stabilized the positive and negative charge that was in our B compound. So in the last step, we're going to be going over the elimination of SO2 from the C compound that we got from our last step in the 3-member ring formation. And so the thing that you need to know about SO2 is the fact that sulfur is happy with 6 or 2 bonds. So in this case, we've got 2 oxygens attached in SO2. And so that is 4 of the 6 bonds that are satisfied. And so sulfur is going to have 2 more electrons, which is going to be our lone pair that's hanging out. And so when we do the elimination of SO2 from this compound, we're either going to take the electrons hanging out in that bond or the electrons hanging out in this bond and give it to that sulfur. And so if we were to choose this bond, we would just be putting those electrons on the sulfur. And so what happens now is that that sulfur is happy. It no longer needs this bond to be satisfied. And so what will happen with that bond is that's going to come down because when we removed this bond and gave it to sulfur, we left a carbocation here. So now we need to satisfy that carbocation, and so we'll take these electrons and connect them that way, and that's what forms a double bond on the cyclopentane. So if we were to draw that out, it would look like this, with our SO2 having been eliminated and now being its own compound. We're going to want to make sure we double check our work by doing the EU of any molecular formula that's given. And so we've got C5H8. So everybody's got their own way of doing it. So I'm just going to do my way real quickly. And we see that our EU does equal 2. And we've got a ring and a double bond. And so that gives us our elements of unsaturation of 2. And that would be our final product.